Mathematics, Analysis and Approaches, Paper 1, Time Zone 1, HL, May 2025. Now, this is question number 3, which carries 4 marks. He's given us two equations, e to the power of x and e to the power of minus x. He wants us to find the area enclosed by these curves and between the lines x is equal to -1 and x is equal to 1. So this is a paper 1 question, and we don't have the luxury of using the calculator to understand the curves, the point of intersection, and what curve to take first and what curve to take next. All right, and therefore it is important that you know some standard equations like e to the power of x. How does it look on the graph? And all of these lines. Okay, so let's quickly plot this. A line x is equal to -1 is a line parallel to the y-axis at a distance of -1, and y is equal to x is equal to 1 is going to be a line parallel to the y-axis, and this is at a distance of 1 unit from the origin. E to the power of x is going to be something like that. Now, this function is never going to be cutting the x-axis, because no matter what value of x I put in over here, right? No matter what value of x I take, this function is never going to be a 0, and therefore the x-axis is going to be the asymptote for e to the power of x. I also know that when the value for x is 0, this becomes e to the power of 0, and hence the y value is going to be a 1. Therefore, the curve is cutting the y-axis at the point 0, 1. Now, when I take the equation y is equal to negative of e to the power of x, the entire curve is going to have a reflection along the x-axis, and therefore we will have a mirror image. Okay, and this curve is going to be cutting the y-axis at the point 0, -1. All right, so these are the points, the end points, and the area that I'm supposed to be finding is that. Let me quickly shade that area. The required area is A, B, C, D. What I can do is to calculate the area A, B, E, F and multiply it by 2, because the curves are going to be symmetrical, and the area that I'm going to be integrating will be e to the power of x from the point x is equal to 1, -1 to x is equal to +1, and then I can double it. That's going to be the required area. Let's quickly do that. Required area is the area A, B, C, D, A, and I can write that as twice the area of A, B, E, F, A. So how do I get that? I can say this is twice integral from -1 to 1 e to the power of x dx, which is nothing but twice e to the power of x integral is e to the power of x itself from -1 to 1. So I can go ahead and simply substitute the value. This is going to be twice of e to the power of 1 minus e to the power of -1, and therefore the area is simply going to be 2 times of e minus 1 over e, and that will be the required area. That's it for this video. Thank you.